All right, letter C. Describe the strategies you have used for solving linear equations. When might you use one over another? All right, so when I think about this different strategies we've used for solving these, it always had to deal with that, thinking about the pouches and the coins. If I had coins on both sides, I needed to get the coins to one side. If I had pouches on both sides, I need to get the pouches to one side. And so depending upon if it was an adding or subtracting, or a positive or negative, I would need to add or subtract. So remember, if it's a positive value, I need to subtract from both sides. If it was a negative value, I need to add to both sides. Then that next step came down when I simplified and I had my pouches on one side and my coins on the other. I was almost always dividing by the number of pouches on both sides to find out how much was in one pouch or that one value of x. There was that one case where we had the fraction, it was on 2a, where we had the 1/4 x. And we can't divide by fractions, so we have to multiply, or we can multiply by fractions, we can't divide by fractions. Gosh, that was a mess. Let me start over. When we have a 1/4 times x, we're supposed to divide by fractions, but we can't because we have to use that multiplicative inverse. So we end up multiplying by that on both sides to find out that value of x. So a lot of those strategies, they repeat often. You generally are dealing with an adding or subtracting first, then you're dealing with a multiplying or dividing second, and then you have to go back and plug it in and check. So hopefully that will help with some of those strategies. Let's take a look at the ACE work here. All right, for the ACE work for problem 3.4, we are going to be doing 17 through 29. So let's take a look at those here. Okay, look at this. Solve each equation, check your answers. That's what we're doing here. So you have the same process. Remember, distribute the 3 through. These look all the same at the very beginning, except they change what it equals at the end. So be really careful when you do that. 18, look at this, all the exact same process. Well, most of them, they change out some of these pieces here, but a lot of it deals with that distributive property through first to create your other equation. Don't forget to combine those, combine those coins first before you begin to do some moving around. 19, solving equations for x. We have a lot of those with coins and pouches on both sides. Okay. 20, here's what it has. So here's the equation I want you to use for 20 and 21 right here. Find y when x is 4. So what they want you to do is take this 4, plug it in there for x, and do the work to solve for y. So for all 5 of these, you plug that value in, and that will give you the y. In this case, so they want you to plug y in to there, and then figure out what x is. So you're basically creating equations that work like this to do that work. 22, explain how the information you found in exercise 20 and 21 relate to locating points in a line representing y equals 4 minus 3x. Okay. Number 23, this can be a really tricky one here, guys. So it says, in each part below, identify the equations that have the same solution. So in all of these, you look through them, you have A's, all these equal, guys. You can basically, which ones are going to be the same? So here's this. A is equals this. Is this going to be this? You're doing the work. So you see, so it has to all equal, for A, it's going to be x equals 8. So does that match up with all these guys? Find the ones that be the same thing. 24, looking through the work here of these students, which one did the correct work? Where's the errors? And then find the right answer. See, they're both wrong. Find the right answer. Same thing here for 25. They both have the incorrect answer, so help them find the right answer. 26, describe how you could use a graph or a table to solve these. So you could make a table and solve these. How could you just describe it? Doesn't even find the answer, but describe what you could do. 27, use the equation p equals 10 minus 2.5c. Find p when c is 3.2, so put 3.2 in there. For this one, find c when p is 85, put 85 in there. Describe how you use a table or graph for those. Same idea for 28. Take these values and plug them in for D to find M. And then take the values for M, plug them in here to find the value for D. And lastly, 29. You have Kong thinks he has a different way to solve equations by factoring out both sides of the equation by the greatest common factor. This is how he solved the problem in 3.4. So this is going to be one that we did earlier. Look at the work that he did. So is his work correct? Go through and try his method here. Right equation can be solved that way. All right, 7th grade, this is a big assignment. And so we're gonna not do anything more from this until we get back from spring break. So I wanna make sure you guys are really understanding this well, because we're gonna push this back into some graphs and we'll pick up on where we left off when we get back from spring break. All right? Okay, good work. We'll see you next time.